So today we are going to talk about the free radical. So how does a free radical looks like? A free radical looks like it has C, X, Y, and Z. First of all, it has 3 sigma bond. Second, it has 0 lone pair. Third, it has 0 vacant d orbital. Fourth, we have 1 unpaired electron. Fifth, we have neutral carbon. The carbon is neutral. And sixth, we have 7 electron in outermost shell. And seventh, we have the property seventh, we have it has incomplete octet. Eighth, we have it is electron deficient. Ninth, we have sp2 hybridized. And 10th, it is triangular planar. And 11th, stability is inversely proportional to electron withdrawing group. So its stability is inversely proportional to the electron withdrawing group. These all the property we know about the free radical. Now, there are some natural tendency of free radical. What does natural tendency of free radical? First of all, it does combine with combination. It is combined with another free radical like C, X, Y, Z. We have one free radical. C free radical, X, Y, and Z. We have second free radical. So when they both are two free radicals, they have tendency to combine. First of all, C, X, Y, Z, X, Y, and Z. That's how they combine. Because they have a free radical, that's why they have 7 electron. They try to make it 8 electron. That's how they combine. And if you like activation energy of the reaction, activation energy is 0 because it has already 7 electron, and this graph comes look like this energy. This graph looks like this because it do not need any energy to activate, because it has 7 electron initially, but it has 8 electron final, and it completes its octet. So it do not need any energy to proceed the reaction. Spontaneously this reaction happens. Next tendency of free radical is disproportionate. Now how does free radical disproportionate? Let's say we have 3 degree of free radical which combine another free radical which is also of 3 degree. That's all. So what does disproportionation means? Disproportionation means there is removal of hydrogen and addition of hydrogen. Removal of hydrogen leads to oxidation, and addition of hydrogen leads to reduction. So here hydrogen removes and gonna add here. So when this hydrogen removes, this lone pair gonna form a double bond. So we have CH3, CH3 and CH3. But there is a transition. Surely there will be a transition state. So let's look the transition state. We have transition state like CH3, CH3 and CH3. We have hydrogen, CH, CH3 and CH3. And one more we have CH3 over here. That's low. Right. Now this hydrogen forms double bond with it, and we have CH2 over here. There is a little bit connection. This is the transition state which we're gonna follow. We have a CH3, CH3, and CH3 free radical. Then HCH2, C free radical, CH3 and CH3. So this is gonna add here and this is gonna remove here, and there is a formation of double bond CH3 CH3 CH3H plus H2C CH3 and CH3. So this get reduced and this will get oxidized. One get reduced and another get oxidized. So that's how it is called a disproportionation reaction. Now, if we look another compound, we have this one and we have this one. So it has tendency to get reduced and oxidize as well. But here we do not, because it is a disproportionation reaction, so its activation energy is not zero. Energy versus reaction coordinate, its activation energy is not zero. It needs some energy to complete this reaction. Now, when does a free radical combines and when does its free radical disproportionate? Let's look. Combination or disproportionation. When we have methyl free radical, when we have CH3 CH2 free radical, when we have CH3 free radical, when we have CH3 CH3 and CH3 free radical. When we go from top to bottom, first CH3 only shows combination, and CH3 CH2 majorly combination, and the 2 degree shows combination plus disproportionation, and the 3 degree shows majorly disproportionation. Now when we increase the temperature, this is the pattern we follow, but when we increase the temperature is increased, percentage disproportionation increase. Why? Because percentage combination decrease. Because in disproportionation we need some activation energy, so its activation energy is not zero. So when we increasing the temperature, we are providing it some activation energy. That's how the percentage of disproportionation increases. Now talk about some examples of biradical. So the thing to keep in mind: 1 degree we have majorly disproportionate. We have majorly combination. 1 degree combination. 2 degree we have combination plus disproportionation, and 3 degree we have majorly disproportionation. So let's solve some problems. We have this compound. So this is actually 1 degree. So this will form this. Second, this is 2 degree. So this will form first combination and another disproportionation. Third, it will show disproportionation. Third will show disproportionation. Fourth, this will show disproportionation. Third will show combination. Fourth will show disproportionation because it is a 3 degree. Fifth, pH CH2 free radical. It will 1 degree and it will show combination. Sixth, it is 3 degrees, so it will show disproportionation. Hydrogen will add, and another time hydrogen will remove, and it will show a double bond. Seventh, this we have, and this is biradical, and this will show form a double bond. Now, when there is intramolecular biradical, we have, so intramolecular reaction goes fast, so it will form a, whenever we have intramolecular, here we have intramolecular first addition first take place. Here also intramolecular addition first takes place. Ninth, we have this type of radical, then intramolecular first take place. When we have 10th, here also we have two biradical, so intramolecular redox reaction takes place. 11th, intramolecular redox reaction takes place. 12th, it's gonna go here and gonna go here, and that's how reaction takes place. 12th, here we have radical, so this bond breaks, and that's how. So whenever we have intramolecular biradical in within a molecule, then intramolecular addition first take place. 13th, here also intramolecular redox reaction takes place. 14th, intramolecular redox takes place. 15th, we have benzene ring. In benzene ring we have two molecules, two until then they will combine. 16th, when 16 combines, it forms, it doesn't form 16, it doesn't combines like this, because when it will combine like this, it will form non anti-aromatic, it will form anti-aromatic, so it will go, it will combine, it will combine with another molecule. This is a quite important question. 17 is also a good problem. We have phenyl, pH and pH carbon over here. So what happens, this lone pair goes to one this side and another this side by resonance, and these two combines. So that's how we see there how the natural tendency of free radical.